Welcome back to the 283 350 build. Again, we're building a pair, a left and a right hand rotation. Chris-Craft 283, actually the Riva Chris-Craft, they called it Riva Special. This is going in a 1966 Akurama. And we left off basically where we were putting on the intermediate rear housing and then putting on the transmission. Everything pretty straightforward with that. We covered that in the last video on preparation of the gaskets and putting everything together. Just a couple of tips. I put some high pressure grease on the snout of the transmission just to ease it going into the pressure plate. Also, the gentleman that redid, Harpus Marine, that redid the transmissions, certainly cautioned me to take careful measurements and make sure that the snout of the transmission does not touch the end of the crank or the drive assembly, the damper assembly. So I did measure that, but he also sent along a fairly thick gasket that he used versus the thinner gaskets that you get in a kit. So I used the thicker gasket. Everything went together very, very nice. You shouldn't have any difficulty kind of wiggling and sliding the transmission right in place and then bolting it up. You know, it just slides onto the studs, and then you've got a couple of special bolts, like this bolt right here at the bottom, and you're all set. So did that, and got the engine, entire engine primed and painted. I'm happy with the way that turned out. And so basically we're now ready to start the outside assembly. Everything is looking good, and we're going to go through that step by step and walk you through exactly what I'm doing, why I'm doing it, and all the parts related to that. Okay, first thing we're going to do is put on the exhaust manifolds. We've got our new fasteners, stainless steel, 4-inch 3/8 by 16s with a lock washer and a flat washer. Going to be using the Permatex copper. That's stainless steel to steel. And on this side, you can see I just slid the bolts in, dropped the gaskets onto the bolts loosely so you can see that. Preparation, just made sure I scraped all the paint off of the surfaces that are mating, and there's our gaskets there. Also, I do want to put a little bit of a plug in for these torque wrenches, the CDI torque wrenches. This is a Snap-on company. It's not a Snap-on, but it is a Snap-on company, and read a lot about these and saw the reviews of them, and bought a set and really impressed. So, you know, if you're not able to spend $400 or $600 on a torque wrench from Snap-on, this is a great alternative that looks to be a really good quality product. Comes with a certificate of calibration, and I've really enjoyed using them. I've got two different sizes, an inch pound and a foot pound unit there. So we'll put these on and we'll torque up to 25 foot-pounds, and then move on to the front of the engine and start installing alternator, water pump, pulleys, brackets, and so forth, remote oil filter, that type of thing. And we'll look at that next. Okay, we're gonna install the starter. A couple of quick notes on that. Two of the bolts are going into the housing of the snout of the starter, so that's going into steel. So I'm going to use the NICs on that, the copper, and actually, I'm sorry, one of the bolts is going into this. Two of them go into the aluminum housing right here and here. So that has got my Loctite Marine NICs for going stainless steel into aluminum. Also, I've just kind of put some lube on the gear on the end of the starter, the Bendix gear, And just a quick note on this is just remember that your starter turns the opposite direction of your flywheel. And when you think about it, a gear to a gear, that makes a lot of sense if you draw it on a piece of paper. So just if you're confused about which is standard rotation and opposite rotation, the gear will be turning the opposite direction. So you can test that out on your starter before you install it. And for instance, I marked on mine starboard standard rotation, which is the engine I'm working on, and had this starter completely restored, gone through, painted, new solenoid on the top, and so it should operate well. We're going to install it, and after I time the engine and stab the distributor, I'll spin the engine without any plugs in it, just to make sure that our starter is engaging in our ring gear properly. Good shout out to a great friend, Eric Thearling, who's very knowledgeable on this. If you're hearing any kind of grinding or the Bendix isn't disengaging properly, might need to shim this out a little bit and play with that just a little bit. So hopefully, fingers crossed, it'll go on just fine and it will engage and disengage properly and won't have to mess with it. But just be aware that that's a good thing to check prior to starting the engine up, or certainly installing it in the boat. If you just spin it through with no plugs, listen to how the starter is engaging and disengaging. These are just 3/8 by 3/4, and then a 3/8 by 1, which goes through the front of the housing here and into this threaded part of the starter. Okay, in this section, I flipped around to the other side of the motor, and we're going to start working on the front side of the motor. First thing you want to do is install the water pump pulley housing. Just a little bit about these. So the Chris-Craft 283, the early part of the production, or up to probably the mid part of production, they used a generator and the water pump attached to the back of the generator. And some, but not all, I believe, were water-cooled generators. If you have that version, you just kind of need to work through those nuances of that application. Total production for the 283 was quite a few. A little more than 41,000 engines were produced from 1959-ish to 1968. Of that 41,000, a little over 19,000 came with in the later part of the production. 19,000 of them came with an alternator, where they switched from the generator to an alternator, and that's where this drive housing unit comes into play. So this replaces that generator there, and you put in the drive housing. So you might have the older version, or you might have this version. Whichever version, it's a similar situation to get it installed into the front housing. A key thing here is the belts, and I've talked to a lot of people and kind of studied this itself. And this particular core engine also had some very old looking original belts, and that further confirmed the correct belt. This is the correct replacement belt. This happens to be a Gates brand, but I believe you can find this in other brands. But what it is, it's the style of the V-shape that fits into this pulley, as well as the pulley on the front housing here, on the front of the engine on the flywheel. And the critical part is that this fits down into that groove and doesn't stick out, as you can see here. It fits very nicely into that groove. An example would be, here's like the alternator belt, more of an alternator automotive type pulley. And you can see here how much of that belt is sticking above the pulley. they just don't fit down in there well. And many people I've known have had problems when they use these types of belts. They'll burn them up. So you want to look for a gauge 6730, or a lot of these applications were like electric motor fan units and stuff that use this kind of this V style, and you'll find them as matched pairs for electric motor, different things. Here's actually the industry number is a 3L300K, 3/8 by 30 inch, 9mm by 760. So that is what you want if you're replacing these belts. Okay, and a word on, so also you want to install, we talked about this earlier in the series, this is the remote oil filter unit that is a replacement for the original, because as we talked, the original 283 block has a single bolt, whereas these newer manufactured blocks have 2 bolts into this oil pickup unit here. And so this has to be replaced. And it's a good thing to go ahead and get that installed before you get the drive housing in your way. So I've got that installed. The basic way this goes on there's a large bolt at the bottom, and this is where your pivot point is. Up here is a single bolt. It's a little smaller, and you can see I've got them laying out here. I'm just using replacement grade 8 bolts, fine thread bolts, just like the original specs were. And you're going to want to have a 11/16, 3/4 sockets and wrenches, and some pretty good sized screwdrivers to utilize the leverage to tighten up the belts. Pretty easy to put on. Basically, you can hang the belts off of the flywheel pulley and then stick this through the hole and get the belts on. The main thing is getting the belts on the pulleys loose and then inserting your bolts into the housing, and then you can work with it. Also, I want to talk real quickly, we've already been through the building of the water pump, but anybody who's taking these off when the engine is in the boat will know the curse words that come out of their mouth when they go to try to get to the back side of one of these water pump bolts. So another shout out to Eric Thearling, but this is the kind of bolt you want to use. It's I think you just call this like a star head. These have very small heads, and that way you can get the wrench on it in many different directions to be able to get to that far bolt underneath there. And also, I had a devil of a time finding the correct lock washer for this, but this is a special high shoulder lock washer. You can see that it matches the diameter of the head here, and that is the correct bolt. And these are just these are 1/4-20s, but this bolt this is the way to go when you put these things together, rather than just dump the hex bolt. I think it's a 7/16 hex bolt, or maybe 3/8, can't remember. Dump those and replace it with this type of bolt. You can find these at a specialty hardware store, or somewhere like my Master Car, but that's what you want to do for that. So I'm going to go ahead and get this installed and tightened up, and we'll be back for the next steps. Okay, let's catch up on some front end work. We've got the auxiliary water pump pulley assembly on there, tightened down. Belts are tight. You can see the belts through this hole here. I don't have a specific measurement, but I've got, they're both tight. What you want to make sure is they're both equally have the same tension on there. And I can push up 1/2 inch or so on each belt. We've got our front mounts pushed in, just a little bit of silicone on your fingertips, and they'll slide up in there, and you can give them a little incentive with a shot hammer, and they'll pop up in there. They should be pretty tight when you get them up in there. We got our front alternator pulley on, torqued down, so that's good to go. Next, we addressed the head outlet and water fittings here for the exhaust manifolds. One thing I like to do, and these are, you're going to have these, and they're going to be original castings, and the pipe fitting or pipe thread in there can be kind of old and gnarly. So I like to chase all the pipe threads with its appropriate tap. It's a 1/2 inch by 14 pipe tap. And, I just kind of like to plan ahead, because for me, I just don't understand the way I understand the way pipe threads work, but they're always, you always stop and it's like they're never in the right place. And you're always worried, will it go all the way around again, or that kind of thing. So I kind of like to test it. If I'm not feeling like it's going to work, I'll run that tap in there a couple more times and kind of just make sure it's cleared out. And maybe if I need it to be just a touch deeper, then I can use the tap to fix that. This outer fitting here is pretty much parallel with the side of the exhaust manifold. Again, I use this is the product I like to use here, the Permatex thread sealant, high performance thread sealant. Use that on all of my pipe fittings. Hose, as we talked about before, I got that from Robert Hinkle. Got the whole hose set, so everything was good there. I wanted to tell everybody about these clamps. I really like these clamps. These clamps are stainless steel German clamps. They're smooth clamps, meaning that the inside of the clamp doesn't have any serrations. There's nothing that can eat on the hose as you tighten it down. They're stainless steel, just really good quality clamp. I found the perfect size. I get these from McMaster Car, and here is the actual part number. This is a W4 Norma 16 by 27 millimeter size. And the actual part number for McMaster Car is 5574K31. So if you look that up on McMaster Car, you'll see the whole series. There's tons of different options for different sizes that you may need. But this size works out perfect. There's nothing worse than having, to me anyway, having a clamp that has 2 inches of extra stuff hanging out of it, and you just catch your fingers on it and that kind of thing. So this is the perfect size for all of the standard hoses on this 283 engine. Works really well. I have a different size on the fuel pump and fuel line. I'll show you when I get to that part, but for the rest of it, all you need is one clamp. And if memory serves, there's something on the order of 14 total clamps. So these come in a bag of 10 for like $13, $14, which is pretty good price for such a really good stainless steel clamp. Let's see here. On this side, this one's always fun. It's a little tricky. Basically, you check this really well before you do it to make sure it's going to make the full revolution. But you put in the 90 street elbow, then you put in this Y fitting without the smooth fitting here, the hose fitting. You're going to bring that around. You're going to tighten these up, and when you put this in there, you can't turn this sideways and have it make a revolution. It'll hit the side of the case. So bring it out this way and have this pointed up, so the Y is up. Tighten that down and get that assembly done. Then you can put in the fitting in the end and bring it on around. And I like to have my hose already cut and on there. And again, I put just a little bit of silicone on the edge inside of that tube or hose. And then as I bring it around, I just put the nose on it, and you can actually just stick a large screwdriver or anything right here in the Y end and just bring it around slowly, and it'll meet up right with your hose, and it makes this super simple to connect up. And again, you've got the Norma hose clamps. So the next thing we're going to be doing is working with alternator. So you want to do this stuff before you put the alternator on, just so you can have easy access. Alternator, remote oil filter. Thing about the remote oil filter, so vast majority of these models, 283 models, did not have the remote oil filter. About the last 10,000, 9,000 and some change units had I'm sorry, I apologize, get my numbers confused. It's actually about 3,300 of the last production out of the 41,000 plus engines had the remote oil filter. So that's about 8% of the total production had this remote oil filter. Now, this was something that I was specifically looking for, this part, because it did, my engine serial numbers show that it did come with these, and it was after a certain serial number that these were standard equipment, but it was only the last 3,300 or so engines right at the very end of the production, so about 8%. So we'll be putting this together with the lines. I'm going to do a little bit of took a little bit of a liberty here, and I'm not going to do copper lines. I battled to try to get these copper lines to work and get them. They just all these crazy bends to go through here and everything. And it really, I think it was a kind of a bit of a hack job originally, and they just kind of bent them and however they could get them, forced them into place. So I'm going with high pressure oil rubber line instead. Sneak peek, that's what that looks like. That engine's pretty much done, almost done. And so we'll walk through all those different parts and pieces I used and what's different from the original copper lines when we come back. Okay, we're gonna finish out this video with the alternator, and I wanted to get specific with it because it's a little tricky. This particular version, to make sure everything is lined up. So the big thing is that the way this alternator works is you have these spacers down here, and these are the original spacers that were with the engine. And the first thing I noticed is that they're really sloppy. They're not 3/8. And so I wanted to do a little better than that. So I went to my industrial hardware store, and I found these, steel spacers for 3/8 bolts. And what you can see back here is there's a 1/4 inch spacer. Here's the original. There's a 1/4 inch spacer in the back. And then between these two mounts here on the actual alternator, you've got a 1 inch, a 1 inch, and a 1/2 inch spacer. Now that gets you really close, or might be right on the money, but if you're not, you've got to make sure that there's no gap here and these aren't loose. So in this particular one, I had to add a thin 3/8 washer to it, and on this end, I had to thin this spacer be just a hair on the grinder, and that way I had a tight joint here between the inside to inside mounts of the alternator. You don't want to squeeze down the alternator from the front and have these loose, because then you're going to be bending your mount and put a lot of stress on the housing of the alternator. This is pretty straightforward. Your aluminum plate, your 3/8 bolts here. This is the stud I remade this stud with a 3/8 bolt, and this is a 3/8 by 24 thread out front that has a lock washer there. Your bolt for your housing up at the top is a 1/2 inch longer than the other bolts, basically to take up for the lifting ring and the thickness of your alternator bracket. Your bolt up here is a fine thread 3/8. Got a bolt, washer, and then you basically sandwich the bracket in between two big washers, and then a lock washer on the back, and then your nut, when that's fine thread nut there. And a belt. This is the belt that fits correctly. This is a Dayco 1365. Now you can look up other brands, but this is the right V-belt and the right length of belt. 1365. I personally like these belts, and I like what they call a top cog, which kind of gives you this these grooves cut in it. I think it looks really sharp. So that's the only trick, is to make sure that that thing fits nice and snug. So when you snug down this bolt, this one and this one, everything is, there's no gaps, and it's not just putting undue pressure on the alternator brackets themselves. Pull back, you know, just kind of use your judgment here, but it's pretty tight, but about a 1/2 inch to 3/4 inch flexion is about right. So hope that helps. And one thing, you know, you might ask, oh, well, you know, Don, how'd you figure all this out? You know which bolts to use and all that. Well, I took the time when I did the full disassembly. So I had a core motor. I had one core motor, and I took the time to disassemble that one core motor, and I cataloged every single nut and bolt and screw, and I bagged them individually. And then I created a master list, and that's how I knew all the different bolts and parts. So when I went to assemble, I had everything in a bag, and I would just reverse engineer and put everything back with new hardware the way it was originally. Also, in the 283, there's a very extensive parts manual that basically walks you through every nut and bolt that puts together the entire engine, and all of that I have found is to be 100% accurate with regards to the parts manual. So that's a huge help. So between that and actually having an original engine to disassemble, you've got it made. If you were doing this completely from scratch, then I would say that the parts manual is your best friend, and you would really want to study that hard to make sure that you could get all those nuts and bolts. If you were like, you know, just buying parts, say if you wanted to actually create a parts engine from Robert Hinkle or someone, and you wanted to double check and make sure you accounted for every Chris Craft marinized part that this project has, you could do that with that manual. So I hope that helps, and look forward to the next installment.